Assalamu alaikum. So this question reads on the forces. A man drives a car over the top of a hill, the cross-section of which can be approximated by a circle of radius r equal 250 meters. What is the greatest speed at which the man can drive without the car leaving the road at the top of the hill? So this is basically we can redraw the figure. A man is driving and then he reaches a hill, and this hill is approximated by a circle of radius r, and here is the car, and the car is reaching the top of the hill, and the question is, if the hill radius is 250 meters, so what will be the maximum speed or the greatest speed can the man achieve without leaving the hill at the top? So at the top of the hill, we know the forces acting on the car. First is the weight, and also we have the normal force. So we can write the equation of motion for radial acceleration or centripetal acceleration. Sigma F should equal ma. And the two forces here, the normal force F normal minus the weight mg pointing down should equal the mass multiplied by the centripetal acceleration, which is also pointing down, because at the top of the hill the direction of the radial acceleration will be toward the center, down. So which means I need to put a negative sign here. So it is basically v square over r. Now the question reads that find the velocity or the speed at which the car will still be in contact. So the tipping point here, or the border point, is that whenever the F normal equals 0, this will be corresponding to the maximum speed. So at normal force goes to 0, V goes to V max. Speed is maximum or greatest. So I need to cross this as 0. So minus mg equal minus m v square divided by r. Of course, the negative sign will be cancelled from both sides, and also the mass can be cancelled, which means in such a problem, the mass of the car cannot be used regardless of the mass of the car. So means that v equal the square root, just do a multiplication, v equals square root of g r, and then we can substitute for g as 9.8 meters per second square, and the r, the radius, is 250 meter, which will give that the v max at which the car will still be in contact at the top of the hill will be 49.5 meters per second. This is the maximum speed that the man can achieve without losing contact at the top of the hill. Thank you. Assalamu alaikum. This is a question on forces and motion. A car traveling on a circular horizontal road of radius 200 meters is almost about to slip. If the static coefficient of the road is 0.15, the speed of the car is. So a top view of the question will be a car traveling. This is a top view. Of course, all of this is horizontal on the surface of the earth. So the radius of this circular motion is 200 meters, and the car is about to slip, which means it reached high speed on this circle. And the question is asking for what is the speed of the car so it doesn't slip. So here, to find such unknowns, we can use Newton's second law, sigma F equals ma. And because it's horizontal, the only horizontal forces affecting this car will be the force of friction. Of course, static friction It has to do with the direction of motion relative to the circle. So it is static friction should equal the mass of the car multiplied by the centripetal acceleration, which is v square divided by r. And the frictional force can be obtained from mu s, coefficient static friction multiplied by the normal force, should equal mass of the car, v square divided by r. And the normal force for this car is equal to the weight force of the car. So mu s mg of the car should equal mass of the car, v square divided by r. Clearly, this problem or this question is independent of the mass of the car, so we can cancel it out. And then v square should equal mu s multiplied by g multiplied by r. Then v should equal the square root of both sides, mu s g multiplied by r. So I can substitute for all these values. We have it. We have the coefficient of static friction as 0.15, and we have g as 9.8, and we have the radius of the circular track as 200 meters. This will give me that v, this is the speed that the car can attain without slipping, will be 17.1 meters per second. Thank you.